the issue. So internetwork routing through an internet poses the same basic problem as routing within a single network. So within a single network, how this routing is done is something we already covered. So that kind of difficulty we are having with the routing in an internet. So this is something generalized, right? So but with some added complication, of course. To start, the networks may internally use different routing algorithm. Right, internally different networks are using different routing algorithms. For example, one network may use link state routing and another one may use distance vector routings. But anyway, right now this is something obsolete and this is what we are using, or its variation. And other than this distance and link state, we can think about some other network routing protocols even. So since link state algorithm need to know the topology, and hope you remember like how this link state is working. So at any point, everybody is preparing that link state packet and they are communicating with anyone else, so that after a single iteration, everybody is getting the link state packet from everyone else, and together it will form the topology internally and they will run the shortest path Dijkstra's algorithm. So the topology should be somewhat same everywhere. In between, some topology change happen and that is not captured by a particular router, so that will complicate things. But no such issue with the distance vector. They do not have any such requirement. So this difference alone would make it unclear how to find the shortest path across the internet. So at that point we are doubtful. So how to find the shortest path across the internet? So networks run by different operators lead to bigger problem other than this. So this topology, that itself one issue, and other than that, when it comes to different vendors who are running, or different operators who run different networks, there are some other problem, like the operators may have different ideas about what is good path through the network, or what are all the parameters that should be tried to optimize. So we already seen many parameters which we can optimize for getting a better routing path. So that concept will be different from one operator to another. Like one operator may want the route to be of least delay, so that could be the requirement of that particular network run by that operator, while another one may want it is to be most inexpensive, so they may be worried about the cost factor. So this will lead the operator to use different quantities to set as the shortest path. The cost may be the delay in milliseconds, or it could be something like a monetary cost. So like that they will set different parameter for the cost, right? So accordingly the concept will change. So what we need is a global internet routing where something has to be standardized, right? So like that many issues will come. So the weights will not be comparable across networks, so the shortest path on internet will not be well defined. So the type of weight used in one network is different for another one, so accordingly it will lead to some issues. So the word said one operator may not want another operator to even know the details of the paths in its network, perhaps because the weights and paths may reflect sensitive information. So that is something, whatever things I am using, whether I use the delay or monetary cost, whatever it is, I don't want it to be known to another one. So these things were normally found to be sensitive information. So that represents the competitive business advantage, right? So finally the internet may be much larger than any of the networks that comprise it. So it requires a routing algorithm that scale well by using hierarchy. So some kind of hierarchy. So when you add hierarchy, the scaling is easy, right? So something like that is needed, even if none of the individual networks need to use a hierarchy. So whether you look at a particular individual network, they may be using distance vector or link state routing, which may not depend on any hierarchy, but all together to scale that routing concept to a very large network, hierarchy is something that will be demanded. So we have the two-level routing algorithm. So it's a hierarchical approach, right? But with which we can deal with the routing problem in a general internet, having the heterogeneity issue. So all of this consideration lead to a two-level routing algorithm. So what is that two-level? So within each network, an intra-domain or an interior gateway routing protocol. So inside every network, when you view a particular network independent of other, inside the network, the type of routing algorithm what we are using is called inside, right? Intra, within. Domain or interior gateway. Gateway is the connecting device, or right now you can assume gateway as an alternative name for the router. So as an interior gateway routing protocol, so that is used, right? So there is another name also, so something we called as autonomous system, right? Autonomous system. and the network that is coming under a particular administrative domain we can call as an autonomous system. So within a particular autonomous system, what is the routing algorithm we used? We can call as an interior autonomous system protocol, right, or intra autonomous system protocol. So like that also you can call. So ultimately it is the routing protocol that is used within a network, right. So it might be any link state protocol or a distance vector protocol, something we already seen. Any one of them we can use as an intra domain routing protocol, or as an interior gateway routing protocol, or as an intra autonomous system routing protocol. So if you look at across the network that make up the internet, so between different networks, how the communication is happening, that is through inter-domain or exterior gateway routing protocol. So here it is inter, here it is intra. Intra means inside an autonomous system, inter means between autonomous system. So here it is interior gateway inside, or here it is exterior gateway routing protocol, right. So that is the common one. So that is something we didn't discover so far. I mean, we didn't see so far. Networks may all use different intra-domain. So from one network to another, the intra-domain protocol may vary, because that is something just for that network, right. So that is not depending on others. But if you look at the inter-domain routing protocol, that is mostly same, because it is to be deployed over the entire internet, right. So in the internet, the inter-domain routing protocol, many were suggested, and the popular one which we are using currently is called the BGP, the Border Gateway Protocol. So that we will see how this is working. It is actually using a kind of algorithm which is somewhat similar to distance vector, but a generalization of it. Distance vector routing, we see many difficulties like count infinity problem and other issues. Those things were solved, and a different variation of that. So some similarities there, but somewhat entirely different to that is what is BGP. Since each network is operated independently of the others, it is also referred to as an autonomous system. That is what I referred before. So accordingly, we can call these things are intra-autonomous system routing as well as inter-autonomous system routing protocols, right. So a good mental model for an autonomous system is just an internet service provider network, the network being run by an internet service provider, all the devices part of it. So in fact, an internet service provider may be comprised of more than one autonomous system also, or the entire ISP network can be considered as a single autonomous system, or you can break it further if it is manageable. So that is the idea of how the routing is done in a general inter-network. Internet particularly, right. So we are using a kind of two-level routing. With the first level we have the intra autonomous system or intra-domain interior gateway routing protocol, so different names, or across different network we are using the inter-domain or the exterior autonomous system routing protocol. Example for exterior routing protocol is our BGP, Border Gateway Protocol, and practical implementation. Similarly, the other one, link state routing protocols like something we already see in the OSPF, right, Open System Shortest Path First, the intermediate system, and if you look at distance vector, we have the RIP. So like that, any protocol can be used within a network, and this RIP is something obsolete, and the OSPF, ISIS, like that, in any one you can depend. Okay, yeah, thanks for watching.